everyone, welcome to the Bridge program in Mathematics. For today's video, we're going to discuss about rational equation. So rational equations, if an equation contains at least one rational expression, it is considered a rational equation. Recall, a rational number is the ratio of two numbers. So that is actually the definition. If you have a rational number, then we expect that that is a ratio of two numbers. So example, 3/5, -2/7, 1/2, and 5/9. Okay? These are ratio of two numbers. Number two, a rational expression is the ratio or quotient of two polynomials. Okay, if a rational number is a ratio of two numbers, then a rational expression is the ratio or quotient of two polynomials. Take note. So example, we have x minus 1 over x squared minus 4, 1 over x plus 2, 5 over x squared plus x minus 2. So these are examples of rational expressions. In the first example, x minus 1 over x squared minus 4. So this is a ratio or quotient of two polynomials because x minus 1 in the numerator is a binomial over another binomial, which is x squared minus 4. The next example, 1 over x plus 2. 1 is a constant and it's part of a polynomial over x plus 2. X plus 2 is a binomial. And then 5 over x squared plus x minus 2. 5 is a constant. It's part of the polynomial over x squared plus x minus 2. X squared plus x minus 2 is another type of polynomial. Specifically, it's a quadratic polynomial. Okay? So note that rational equations have a variable in the denominator in at least one of the terms. Okay, that's very, very important. That's a sign that you can determine if an equation is irrational or not. So one sign, the rational equations have a variable in the denominator in at least one of the terms. So for example, in the first example, x squared minus 4, in the denominator, there is a variable x, right? And in the second, 1 over x plus 2, it has a variable x. And the third, it has a variable x. Okay, so in the denominator, it has a variable in at least one of the terms. Now, solving rational equations. Our goal is to perform algebraic operations so that the variables appear in the numerator. Okay, our goal here is to perform algebraic operations so that the variables appear in the numerator. So that is our goal. We will eliminate all denominators by multiplying both sides of the equation by the least common denominator, or LCD. So in other words, if we have a rational expression, then to eliminate the expressions in the denominator, we will multiply it, okay, to both sides of the equation by the least common denominator. So we are going to identify the LCD in each side of the equation. So eliminate all the denominators by multiplying both sides of the equation by the LCD. Note that finding the LCD is identifying an expression that contains the highest power of all of the factors in all of the denominators. So in other words, the LCD, it's the least common denominator with the highest power of all the factors, because we are going to test if this denominator can still be divided by each denominator of each expression in all sides of the equation. Okay, so how to solve rational equations? So here are the steps to solve rational equations. Number one, factor all denominators in the equation. Again, you have to factor all denominators in the equation. If you have already identified and determined that the equation that you have is a rational equation. Number two, find and exclude values that set each denominator equal to 0. So we are going to look for the values of x, okay, that can make the denominator 0, because earlier we take note that we cannot divide a number by 0. Okay? And then find the LCD. So after excluding the values that can make the denominator 0, we are going to find the LCD. Number 4, multiply the whole equation by the LCD. So if you already have the LCD, then you're going to multiply that LCD to the whole equation. So meaning to say to both sides of the equation. If the LCD is correct, there will be no denominators left. Again, multiply. And then number 5, solve the remaining equation. Number 6, make sure to check solutions back in the original equations to avoid a solution producing 0 in a denominator. So since we are talking here a rational equation, we are discussing a rational equation, one of the steps is to make sure to check solutions back in the original equations, because in this case, we may get an extraneous solution that is a value of the variable that can make the equation false, or in this case, that can make the denominator 0, because we cannot divide a number by 0, so it's false. So again, make sure to check solutions back in the original equations. So example 1, solve the rational equation 7 over 2x minus 5 over 3x is equal to 22 over 3. So this is a rational equation because each term, okay, the first term, for example, 7 over 2x has a variable in the denominator. The second term, 5 over 3x, has a variable in the denominator also. So they are quotients or ratios of two expressions where the expression in the denominator has a variable x. Solution. What are the denominators? You identify the denominators, 2x, 3x, and 3. Next. What's next? LCD must contain 2x, 3x, and 3. So the LCD is the least common denominator. So what should be the LCD? The factor, okay? The common factor in that denominator that has the highest power that can divide each denominator in each term of the equation. So what should be the LCD? Okay, so in this case, no factoring is required. Why? Therefore, the LCD is 6x. It contains all the 3 denominators. There is no factoring is required because that should be the next step, right? But in this case, in this example, it's already factored, right? 2x, 3x, and 3. So there is no factoring that is required in this example. So we proceed to finding the LCD. Now the LCD is 6x because 6x can or consists or contains all the three denominators. In other words, 6x can be multiplied by 2x, can be divided by 2x, can be divided by 3x, and can be divided by 3. So again, that's our LCD. Each denominator can be divided evenly into the LCD. So let's proceed. So here we have 7 over 2x. We copy again the given equation, minus 5 over 3x is equal to 22 over 3. What's next step? The next step is to multiply both sides of the equation by the LCD 6x. So that's 6x times the quantity of the equation. Okay, so we multiply 6x in all sides, in both sides. So we have 6x times this one. Use the distributive property to simplify this. That is, we multiply 6x times 7 over 2x, 6x times 5 over 3x, and then 6x times 22 over 3. That is by applying the distributive property. Again, use the distributive property again. So 6x times the quantity of 7 over 2x, okay, minus 6x times the quantity of 5 over 3x equals 6x times the quantity of 22 over 3. So we just simply use the distributive property. Okay, continue. So we have 7 over 2x minus 6x. 6x times 7 over 2x minus 6x times 5 over 3x is equal to 6x times 22 over 3, and then simplify that. So first, one way to simplify is to cancel out the common factors in the denominator as well as in the numerator 6x. So what are the common factors of 6x and 2x? 2x, okay? So 6x or 6x divided by 2x. So 6x divided by 2x, the GCF is 2x, so the answer is 3. That's the simplified form. 6x divided by 3x is equal to what? Is equal to 2. While 6x divided by 3 is equal to 2x. So we are now having a simplified equation. Okay, that's why it becomes 21 minus 10 is equal to 44x, because 3 times 7 is 21, minus 2 times 5 is equal to 10. 2x times 22 is equal to 44x. And next is multiply remaining factors by each numerator. We already did that. So this time we simplify, we combine like terms. So we have negative 44x. So what I did, I just put it 44x on the left side for easy to compute. So negative 44x is equal to negative 21 plus 10. Okay. Then negative 44x is equal to negative 11. That's the answer of negative 21 plus 10. And then we just simply multiply or divide by what? Negative 44. That's why our value of x is 11 over 44, or is equal to 1/4. This is the solution. Now, are we sure that this one is really the solution? Okay. Example 2, solving rational equations with a binomial in the denominator. Solve and find the solution set of the rational equation What's the rational equation? X over x minus 3 is equal to 5 over x minus 3 minus 2, minus 1 of 2, minus 1 half. I mean, x over x minus 3 is equal to 5 over x minus 3 minus 1 half. And as you notice, we have denominator on the left side, x minus 3, and the denominators on the right side, x minus 3 and 2. Okay, so perform the next step. So we have the denominator x minus 3. Okay, so we just simply copy x minus 3 because they are common to both terms. So x minus 3. And then for 1 half, the denominator is 2. That's why we can use also 2, and we multiply that one to our denominator x minus 3. So it becomes the quantity of x minus 3 times 2, or we can interchange. Like we can rewrite into 2 times the quantity of x minus 3. So what is this one? This is what we call the LCD. So this is the LCD of the given equation. Okay. So again, what's the LCD? The LCD is 2 times x, quantity x minus 3. So what's the next step? The next step is to multiply the LCD to all sides. Okay. So that is, and then you apply the distributive property, 2 times the quantity of x minus 3 times x over x minus 3. That is what we mean by that. And then you multiply 2 times x minus 3 by 1 half, and 2 times x quantity x minus 3 by 5 over x minus 3. And actually, you can simply use the LCD on the left side, then you multiply that one to the right side expressions. So we multiply that one, and then we cancel out to simplify the whole expression or equation. So since x minus 3, they are common, so this can be canceled out. And then x minus 3 on the right side is canceled, as well as in 2. So what is left here is, what's left? We just simply multiply 2 times x. That is 2x. Okay? 2 times 5 is 10. And then we simply multiply the quantity of x minus 3 to 1, because x minus 3 is not common to the term 1 half there. It's only 2 that is common. So that's why minus the answer of the quantity of x minus 3 times 1. Okay? Then you simplify that one. We have 2x plus x. We just combine like terms. So 2x plus x is equal to 10 plus 3. So this becomes 3x is equal to 13. And then x becomes, or x is equal to 13 over 3. How did we get this? So we got this by multiplying 3x is equal to 13 by 1/3, or by dividing it by 3. So x is equal to 13 over 3, and we have the solution set 13 over 3. Now, in your case, if you are asked to solve a rational equation, it is required to test whether the value that you got is really a solution by performing the checking, the usual checking. You simply substitute the value that you got to the original equation. Okay? But in this case, you can verify that one, that x is equal to 13 over 3 is really a solution of the given equation. Okay, there is an important remark. It is always important to check your answer. Even if you never make a mistake, in your calculations. So even if you are sure that you have no mistakes in your calculations, but still it is required for you to check your answer. This is because you sometimes end up with extraneous solutions, which are potential solutions that do not satisfy the original equation. Now, what we did not check, right? Because we already knew that that the value that we get is really a solution. So in your case, you have to check if it's a solution or not by just performing the usual checking. Okay? And then you try this. Solve the rational equations below and check your answers to determine the solution set. Number 1, 2 over x minus 2 plus 1 over x plus 1 is equal to 1 over x squared minus x minus 2. And number 2, 2 plus 5 over x minus 4 is equal to x plus 1 over x minus 4. So these are the rational equations that you need to solve to test if you really understood the lesson. And if you really have questions or if you have concerns while you're solving these equations, you can post it there in the forum section. You can ask your instructor. Okay? So thank you very much. And we hope that you learned something from this video. Bye.